All right, there they are, our adoring fans. I called you all our adoring fans. So don't make me a liar.
Are you telling them to adore
You must
us?
adore us
that
now.
feels weird. It's weird.
What does it mean to adore someone? I mean, oh yeah, okay. For some reason, that word sounded weird all of a sudden when I said it by itself.
Well, we said it too many times.
Yeah, I think that's what it is. Because like, I adore you. You just like something a lot.
Adoring.
In fact, you
like
might love
like
it.
Higher than like, and like different than love. You know?
Is it different than love?
I think so. I think it's more like
more devoted, more no, maybe not.
Yeah, like more, you also admire them a little bit. More
obsessive, maybe.
Not so much. I think admiration more.
Okay.
Like you're impressed and by this person. Now, okay. But I feel super weird talking about it that way because now we just gave that to.
I said that everybody has to be obsessed with us, and you said everyone has to admire and and look up to us.
Yeah. Right.
All right.
Yeah. Well, adore is from French. J'adore means love, but like, I think it's one of those words that was taken and changed. Yeah. Like it was a French word that like English people were like we were like, oh, we like the way that word sounds. So we're gonna change it.
Tweet. So we got a live chat room here. The chat. We're talking to the chat room. They of course know they're live, but this is also going out to patrons. It's being recorded. We're doing this another live show, and Tweep is here. I feel like I haven't seen Tweep in a while. So hey, Tweep.
Tweep. Yeah, it has been a while.
We also have Ken Hayes, Cryoemer. That's Logan's here. Hey, Logan.
Cryoemer. We got Ken Hayes.
Yeah.
That's fun to say. Ken Hayes.
I feel if I knew Ken Hayes, I feel like I'd always say the whole name, right?
Ken Hayes.
Like, hey, yeah, I talked to Ken Hayes today, or Ken Hayes is coming over later.
Yeah, I agree. I'm a fan when I have somebody whose name starts with J in my life. I like to change it to a Y.
Oh yeah, that's
for funsies. Yawn, Yennefer.
Yeah, that's some real dad humor right there.
Is it? I just
yeah.
I feel like I'm just being like silly, generally silly.
Well, yeah.
Yamez. I knew a guy named James. I called him Yamez.
It's kind of like pronouncing the J like an H, as if it was Spanish, like in saying, or all the time, you know.
Like saying quesadilla.
Or yeah, saying Spanish words and pronouncing the J as a J, like jalapeno.
Jalapeno.
Yeah. Are
we being racist? I think we're being racist.
I had a world geography teacher in high school who did that all the time. He said jalapeno, just like that, jalapeno. He would he was our speech and debate coach too, and so we'd be at like speech and debate practice, and he would buy someone. There was a Subway at the place next to the high school, and he'd buy someone a Subway sandwich if they went and picked one up for him, you know. But he always wanted jalapenos on his Subway sandwich.
Oh my gosh, that's so smart. It's like
it's kind of like DoorDash before DoorDash.
Yeah, pre-DoorDash, except high school students.
Yeah.
That you're responsible for. I like it.
You're supposed to be monitoring, being responsible.
Yeah. That, that's a life skill. Ordering a Subway. That's a life skill.
Yeah, exactly. He was teaching us how to do that. But hey, everybody, it's a fun live show. I had to stop my movie. We're watching Ant-Man and the Wasp, continuing our journey through the MCU with the kids finally. Yes. And I stopped it halfway in order to come and talk science with all of you. But Maura, I was going to ask you while we were chatting before we started recording, but I decided to save it for now when we're chatting with everybody else, to ask you how your vacation went.
Yeah. Well, we have created a little bit of a family tradition when we travel typically to the Okanagan at some point in the summer. And
the Okanagan, I've heard that before, but maybe I've heard it from you.
Probably.
Yeah.
It's a very Alberta place to vacation. Well, yeah. I mean, a lot of people go there. It's a beautiful, beautiful lake, warm, and rocky, and just delightful. Yeah. And my folks live near there, and so our tradition every year we get an Airbnb, and we will spend the whole like morning at the beach, morning/early afternoon. Like my kids will go 7 hours to a beach. We go hard, and then we kind of crash in the afternoon and watch something from a series.
Yeah.
One year we watched this reality show where people competed to set up crazy domino structures. I think it was called Domino Masters. It only had one season. But we got super into dominoes, and one year we watched all the Sonic movies, and this year we watched all of the Spider-Man movies.
Oh, that's cool.
The most recent ones because of the new one coming out. However, our vacation was unfortunately derailed.
Oh, no, don't tell me that.
Because, we were all set and ready to go to the Okanagan, and then, like, the whole place caught fire.
Oh, that happens
my parents
up
were
there
evacuated, and yeah, it does. It's a common thing, and always a risk. But it was literally the day we were about to go out, they got evacuated, and so I was kind of glad that it didn't happen while we were there.
Sure, yeah.
Like that, I think would have been a lot worse.
Still disappointing.
And, it was very disappointing. It was upsetting. The kids were sad. We were sad. We're gonna meet up with more family there, and so everybody was sad.
Yeah.
We made the most of it. We ended up hopping around to a couple of other places around the province and visited some other family, and yeah, it was a good time with the fam.
You made the most of it.
We all enjoyed ourselves. We did make the most of it. But that lake is really magical. It's something else. It's like a really amazing place. And I grew up going there because my grandparents lived there, so it feels like it's an important place in our family, and we just didn't get the chance this year.
Bummer.
But my parents were safe, and their home was okay. It did not get burned.
Oh, well, that's good.
No big damage. Yeah. So I'm really grateful for that. They did know a couple people who lost their homes, which is awful, but they're all back as of now. This was a couple weeks ago. So yeah, it was a mixed bag, my vacation was, but we did watch all of the Tom Holland Spider-Man movies. And
it's funny that you say that. My daughter was invited to a friend's house last night just to watch a movie with her friend and their family, and they were going to watch Spider-Man movies, and one of them, and she was really worried. She was like, I've only seen the first one, and this was really sweet of her. She was like, what if they want to watch one of the other ones? And I was like, well, you can watch one of the other ones, but she was like, but we're watching them all together in order, and I don't want to watch it without you first.
Aww.
I was like, oh, that's really sweet. That's really nice. So they didn't. They watched the one that she's already seen. Of course they did, because they're nice people.
That's sweet.
But yeah. So we're working our way through it. And
how far through the catalog are you? Where is Ant-Man and the Wasp? That feels like it's pretty far along.
It is towards the end of the Infinity Saga. It is after Infinity War, but before Endgame. In fact, it's the movie that came out right after Infinity War. So there's Infinity War, then there's Ant-Man and the Wasp, then there is Captain Marvel, and then there is Endgame. And then there's the second Spider-Man movie, and then that's the end of the Infinity Saga.
Right.
And then then it gets more complicated because we're trying to work up to all of it now, because then there's movies, but then that's when they started all the different like Disney Plus series. And so we have to, but not all of them are really necessary to watch. and like in terms of trying to make sure you stay in
There's
the
so many.
yeah.
I saw the Immortals, but I haven't seen the most recent Captain Marvel one.
Mm,
But I did watch the Miss Marvel series,
that was good.
which was great. What a great series.
Yeah, the kids
Highly
saw that
recommend.
actually. I'm grabbing a drink real fast, but I can still hear you.
Yeah, it's one I watched by myself, but would love to watch with my kids. Actually, I think
Yeah.
they're at the right age. My daughter's maybe a little young, but I think it would be really good.
Yeah, it's
And I learned a lot about the history of India and Pakistan that I did not know before.
Yeah, that was really cool how they
I've
worked
been there.
in all that, because I didn't know any of that about India and Pakistan either. But yeah, that was a good one. That was the first Marvel anything that my kids saw.
Really? Oh, cool.
it
Oh, the
took a-
Eternals. Logan corrected me. He didn't correct me. He just said the Eternals, and that's what I meant when I said the Immortals. Sorry, go ahead.
Yeah. And the reason it took us a long time to get started with all of it is because for a long time, Kaylee couldn't handle movies with intense action sequences.
Yeah, it's a lot.
That were live action anyway. Like she could do it in animation all day, but live action, sort of intense action sequences were tough for her for a little while. So whatever. We just waited for her to be ready for it, and now we're tearing through them. She loves it.
Nice, amazing,
Yeah.
amazing. I mean, it's good. It's good.
It's so
story,
fun to
fun
watch
times.
things that you've already seen through somebody else's eyes for the first time. I
for
really
sure.
enjoy doing it because I'm not the kind of person who likes to rewatch things. Stephanie's different. She loves she's got movies that she loves to watch over and over again by herself.
Mhm.
I don't really like to rewatch things, but I love rewatching something if I'm watching it with someone who's never seen it before.
That it is a unique joy. I do agree. Bennett and I usually pick something that we watch through together, and our most recent one was Young Sheldon, because I'd already seen it, and same, like I get to watch him watch it, and it's also like, it's like PG, rated, and so it has some concepts that he hasn't really come across in shows before, and so it's interesting to kind of experience that with him also for the first time. Good show. I recommend.
Zoe, my 13-year-old, is kind of like a 30-something or 40-something-year-old in the way she likes to watch. She's like watching House right now.
Oh,
but like just on her own.
that's so funny.
She loves like a medical drama.
Okay, all right. Did she watch The Pit? Is that the medical one?
No.
Or is that the?
Yeah, that's the most recent one with Noah Hawley.
Yeah.
Which is an amazing show. I did watch both seasons.
I haven't seen it.
It's so good. But no, she's not watched that. But she's watched like, but like she loves all the like what I would call sort of like, I don't know, like popcorn medical dramas that are like, that are like network television, like The Good
Grey's
Doctor.
Anatomy.
She would
Okay,
love,
yeah.
She would love Grey's Anatomy if Stephanie would even let her watch it. In fact, she heard about it one time.
That one seems like it was maybe a little more mature.
Yeah, Stephanie was like, "There's no way you're watching that show."
Yeah, I've never seen it, so I don't know what's in it. So fair.
But it's quite got quite mature themes. Okay. But yeah, Stephanie loves or Zoe loves a medical drama. Yeah, she should watch Scrubs. You're right. We should watch that with her. She would love that.
The most recent one is really good.
Is it the new season?
Out?
It's not really a reboot, but
yeah, kind of sort of. It ages really. They aged the characters and the themes of the show in a way that was really entertaining and appropriate. It felt good.
That's good. Well, having said all that, and I don't want to rush us, but I am going to rush us a little bit to get started with the show because my family's like, "How long is this going to take you tonight? We got a movie to watch."
Yeah, right? It's late.
Yeah.
You got to see what happens to Paul Rudd.
Yeah, exactly.
Oh, now I want to watch Ant-Man with the kids. Maybe I'll do that tomorrow.
It's so Paul Rudd is so good, and
he's incredible.
Yeah, love
I
that
love
guy.
him. All right, let's do this.
Do you have anything for the top of the show? I have
see
the
you've
one
got a
mention.
little something.
I have the one mention, but do you have anything else?
Yeah, I do.
That we could like open up with.
Yeah, I got it.
All right.
Oh man, as soon as I start thinking I have to record a podcast, my mouth goes dry.
It's called podcast mouth.
All right, here we go. Hey everyone, it's August 24th, 2026, and you're listening to All Around Science. My name's Maura Armstrong.
And I'm Bobby Frankenberger, and we are two huge fans of science here to get you caught up on what's going on in the world of science. Just generally geek out about science stuff. How are you doing, Maura?
I am feeling quite brave this week.
Are you?
Because I did something that I was quite a little bit nervous about
on
Wednesday. I auditioned
to be
in a choir.
In a choir.
That was the best reaction ever.
That's really good.
I don't
That's
know.
Cool.
Yeah. You know, the process of it was very it wasn't really all that intimidating or anything. Like, other than just singing in front of someone, it's kind of scary.
Yeah, not that intimidating. That sounds very scary to me.
yeah. But like the director was really lovely and warmed me up and eased me in, and complimented my voice, and I was like, ooh, and so I'll find out later, in the week if I got it. So
you don't know yet. Ooh, I'm excited.
I don't know. It was like a real audition, like an actual audition. And it's not like super exclusive or anything. It's not, I think, ultra competitive. Everybody's an amateur, but yeah, I honestly, like, I don't know if they'll take me into the choir, but I do wonder, like, I'm a lot more nervous about the time commitment than anything else. But
so it's
it was
you
really
said it's
cool.
amateur. It's you don't get paid or anything like that.
No, you pay to take part in it.
Oh, okay.
You're paying for like for like the director, and for there's like a retreat, a choir retreat.
That's
fun. Which is crazy.
Yeah. Tell me it's at Christmas time and you get to go around and sing Christmas carols, and that would be amazing.
No, nothing like that. But we would. There was apparently plans for this choir to sing with the symphony orchestra. So so that would be a really cool experience. I feel like sing with a live symphony behind you.
That sounds fun.
Yeah.
That sounds really fun.
Yes, I'm excited.
Doing something.
I hope it works out.
Doing something, performing is something I miss doing in general.
Me too.
Because I did in high school, really like on a stage performing. The last time I did it probably was in high school. I was for 1 year. I think I've told you this before. For 1 year, my first year in college, I was a theater major, but I never got to the point where I did any like performance there. But in high school, and I loved it, and I fantasize about when I have more free time, like maybe when the kids are both in high school or off in college or something, I might find a community theater and get involved or something like that, you know.
Yeah. I don't know. It's a I hear ya. I miss performance. I miss singing. I really miss singing. I like to sing, and
you're good.
I don't know. I feel like I do, oh, thank you. I feel like I do that all the time. I sing all the time on this show, so everybody who listens knows this. Like random, like little songs.
Sure.
I'll sing a sentence, you know, but my kids don't like it when I do that, so I don't do it as much at home anymore.
Same. I like doing funny voices and acting out silly scenarios, and my kids hate it.
They just shut me down so much, and so I don't do it as well. That's a lie. I still do it just about as much. But anyway, it's there's something about singing with a group
Yeah.
that I really would love to do again, and I hope it all works out. I really, we'll see how it goes. But I'm
Yeah.
excited.
That is cool. Well, you know
I'll
what
let you
I'm
know.
excited
I'll
about.
keep you
Yeah,
posted.
yeah.
What are
Let
you
me
excited
know.
about?
I'm gonna ask you every week until we find out. But I'm excited because I just recently got to be on the Daily Tech News Show,
Yay!
which is a podcast. It's a really great tech news podcast hosted by Tom Merritt and friends. There's sort of a bunch of people that rotate in and out of there, but it's Tom Merritt's Daily Tech News. I mean, the title says it all. But one day he called me up or messaged me and said, "Hey, there's this science article. It was about tidal energy, like the renewable energy, tidal energy." And he sent me an article and he was like, "Hey, do you think you would mind chatting with me about this for the show, for a Daily Tech News Show?" And I was like, "Yeah, sure." And so I did a little bit of research and was on the show. So it was fun, and I think we had a good conversation. It's a really great podcast in general, but if you want to check out the episode that I was on, it was the August 20th episode. You should check it out. It's
awesome.
I had a little segment on there talking about that. But the Daily Tech News Show.
Well, if you need more Bobby, then
and who doesn't?
That's where to go.
Who doesn't?
We all need a little more Bobby in our life.
Yeah. All right. Well, having said all of that, are you ready for some science?
I am.
Are you ready for some science?
It's quiet in the chat.
They're intently listening. They like what we're saying. You're echoing?
Usually I answer a bunch of questions. We look at the chat and answer questions.
Yeah, feel free to throw questions out at us, then we'll take a break between segments. But for now, I guess we'll just jump right into the next thing. Oh, this is a good one too.
I'm excited.
Maura, you remember Moderna?
Oh yeah, remember when all we talked about was which pharmaceutical company had come out with which vaccine?
Yeah, and it was Moderna. It was what was the other one? Moderna really kind of Pfizer, sure.
Johnson and Johnson. We were like, who's gonna get full approval first?
Yeah, it was the battle of the pharmaceutical companies. Yeah. Well, we haven't heard a lot from Moderna in a while, just because they were existing in the news in a very particular time that we all cared about. But they are back. They're back.
Hello. Welcome back, Moderna.
Left. They were always working, but they're back in the news. This past week, I saw so many headlines about Moderna. Their whole thing was mRNA technology. That's why we were talking about them. They were a relatively new player on the scene. I mean, they weren't like a new company, I don't think, but their whole thing was this mRNA technology that made the COVID vaccines, and so they went all in on that, and it was great, and we all benefited. That's what kind of put them on the map. And I remember when we were talking about it, do you remember there was lots of excitement about how not just the vaccine itself, but about how the mRNA technology that they had developed for the vaccines, how that could be extended to be used for a lot of different things, right?
For many things.
Yeah. Like a lot of different medical treatments, how it could make vaccine technology and vaccine targeting a lot more agile and quicker turnaround on vaccines and all this kind of stuff. And it was there was talk about immunotherapies for diseases, customized treatments, all this kind of stuff. But so they're back, and exactly for that they have developed a personalized mRNA cancer vaccine.
Personalized. Tell me what that means.
Yeah. So here's the news. Moderna and Merck together. Merck is another pharmaceutical company. they've announced a new personalized mRNA cancer vaccine that has succeeded in a phase 3 trial for melanoma, which is a type of skin cancer. The phase 3 trials, if you remember, reach way back to our all of our vaccine knowledge. We all became vaccinologists or vaccinologists. That's not the word. What is the word? Virologists?
Immunologists. Anyway.
That's the word I'm looking for. Thank you. We all became experts back then. You might remember phase 3 trials are when they're testing medical treatments on large groups of people in real clinical settings to see if the drug is going to work at scale in the real world, right? And so that's what this is. This cancer vaccine, they're calling it, or at least the headlines are calling it, it has passed phase 3 trials. They're calling the drug, the treatment, intismeran autogene, or intismeran for short. And what they've said about it is that it met the primary endpoint of recurrence-free survival. It's very technical language, right? Basically, what that means is the primary goal was for people who take this drug to survive without their cancer coming back. That's recurrence-free survival. And then the secondary endpoint of, this is, again, really technical, distant metastasis-free survival. Now, what that means is the distant means somewhere else. So you've got your cancer, that's your local tumor that where it exists. Distant means somewhere else in the body, and metastasis means that it's cancer that has moved, right? Or that it's cancerous.
Yes. Is that pronounced metastasis?
I think you can pronounce it both ways.
Is that both?
Yeah.
Both? Yeah.
I know I've heard different doctors say it both ways. But yeah, metastasis. So distant metastasis-free survival. That was the secondary goal or endpoint, was to see people who take this. Also, not only did they not have their cancer come back, but the cancer didn't go anywhere else in the body either.
Gotcha.
Great. And they tested this on patients with high-risk melanoma whose tumors had been surgically removed already. Okay.
All right. Okay.
I feel like you wanted to ask a question, or am I just?
No. That's awesome.
All right.
I'm with you.
All right. So how does this work? That was my question. So I looked into it. Personalized means that it's basically they take whenever they are removing the tumors, they keep the cells, they keep samples of the tumor, and so they use those tumor cells to sort of get the DNA out of them and get data out of them, and use that to personalize an mRNA treatment that was added to an existing cancer treatment. That's where Merck comes in. Moderna's making this mRNA treatment, but it works alongside of Merck's existing drug called Keytruda. You may have heard of it.
Okay.
I feel like I've seen Keytruda advertised on like Hulu commercials before.
Wait. Oh, that's weird.
Yeah.
Is it specific to cancer?
Yeah, Keytruda is an immunotherapy cancer drug. Yeah.
Okay.
But this mRNA treatment is different than chemotherapy or immunotherapy. So chemo, very briefly, chemotherapy, what it does is it kills both healthy and cancer cells. It just sort of targets fast multiplying cells, and so it's a big hit all over the body, kills all those cells. Immunotherapy is different. Immunotherapy, what it does is it gets the immune system all revved up so that it can start attacking things more readily. But what this personalized therapy does is it trains the immune system to specifically target a single patient's tumor cells only. So that's why it's personalized. This was designed, these mRNA pieces were designed and made specifically for an individual patient, like one person.
And Keytruda, you said, is an immunotherapy drug.
Yeah.
So this is kind of those things hand in hand. do this,
Yeah.
helping the body, rev up its immune system while helping it target to a
Yeah.
specific
Well,
spot.
because the way Keytruda works is it gets it makes our T cells able to keep. So in your body, you have T cells, which are white blood cells, part of our immune system. The T cells have receptors on them, which or they have these receptors called PD-1 receptors. Whenever those receptors get activated, it sort of slows down and stops the T cells from attacking. The T cells find and destroy abnormal cells in the body. They seek and destroy all those cancer cells. And so they have receptors on them, which are kind of like off switches. So whenever those PD-1 receptors get activated, it turns those T cells off so that they'll stop. And you want that because you don't want the T cells to be attacking cells in our body. You want them to be able to just do their job, and when they don't need to be doing their job, they can be turned off, right? Well, the problem is cancer cells are really good at turning off. They have lots of proteins on them which bind and activate the PD-1 receptors on the T cells. So that's one of the ways that cancer is able to thrive, is that it's really good at turning off T cells. Yeah.
Yeah.
So what Keytruda does is it doesn't stop the cancer cells from doing anything, but what it does is it sort of like puts a shield around the PD-1 receptors on the T cells so that nothing can bind to it, so nothing can turn them off. It's kind of like if you go to all the light switches in your house and you put like a piece of duct tape over it so nobody can flip the switch. That's what's happening. Like it's just blocking the receptor. It's not binding to it or anything. It's blocking it so that nothing else can activate it. And so the T cells can just keep attacking. That's what Keytruda does. And then so Moderna, these scientists, they thought, well, what if we, in combination with an immunotherapy like Keytruda, what if we use that to ramp up the immune system, and then we introduce a personalized mRNA treatment to give this ramped up immune system a target, right? To say, okay, you're raring to go, and hand them the picture of the wanted poster. I remember you used to, back in the vaccine days, you would compare it to a wanted poster. Hand them the wanted poster and say, you're raring to go. Here's what I want you to get.
Right.
And so, in theory, that sounds great, but you have to test it, right? So the way they do that is they use like I said, they use the patient's tumor cells to get sort of a fingerprint of the cancer cells, and then they custom make. The turnaround on that is only 6 to 8 weeks. They're able to just say, let's take this and let's make this mRNA vaccine, quote unquote. Only takes about 6 to 8 weeks. They did this they tested it on 1,137 patients. There was a group that got Keytruda, and then a group that Keytruda, or let me put it this way: there was a group, part of the patients got the mRNA vaccine with Keytruda, and part of the patients got just Keytruda alone, right? Without the new thing. And so apparently it looked good. Now here's the caveat: the data's not actually available yet. They're waiting to. They have a meeting upcoming where they're going to share the results with regulators, the FDA, places, publishing journals, and all this kind of stuff. But they said the results are positive. The reason they went ahead and made a press release is for, stock price reasons, all that financial stuff. And it worked. But what we do know is that in the phase 2 trial, the trial before this, the treatment was showing a 49% reduced risk of recurrence and a 59% reduced risk of distant metastasis. So those two things that they were looking for, it showed a pretty significant reduction in risk of cancer coming back or recurring somewhere else.
Amazing.
Yeah. So it looks good. Now, not only is this exciting for melanoma, the reason it's making all the headlines is because, as you might imagine, this sort of general approach to cancer treatment is pretty exciting, and could this general idea could be applied to theoretically to all sorts of types of cancer. And so, in fact, Moderna and Merck are already studying. They're in the process of already studying this combination with other cancers like bladder and kidney cancers, pancreatic and stomach cancers, and there are other companies. BioNTech, another callback to the COVID days,
the COVID
company.
times.
Yeah, they're using a similar approach to develop their own drugs for colon cancer and pancreatic cancer. So
that's so awesome.
Yeah, it's really exciting, really cool.
So I Corbin or Krymer in chat. Apparently this is your area of work. Is that
really
what I'm gathering? I am inferring from the very technical knowledge that you kind of mic dropped into the chat.
Yeah.
That you have
30 short sequences and make it into an mRNA. Yeah, I was reading about it. They had there's a whole bunch of neoantigens, they call them, which are the, you know what an antigen is? It's the proteins that get expressed on the outside of the cell. These neoantigens are mutated antigens that are unique to the tumor cell itself. And when you take a bunch of those together, it creates sort of a fingerprint of the cancer cell, and they can use that to custom make the mRNA.
And well, another interesting point that he made is that if Keytruda doesn't wipe out the cancer, the tumor changes and it's harder to kill the cancer because they can now then ignore the drug. So if it doesn't work the first time, it might not work the second time. So that makes this like even doubly more exciting because
it addresses a problem with Keytruda.
It hits it harder with a drug that might not work the second time around if it didn't completely get the whole tumor. So that's crazy.
Yeah, this is really exciting. I pay a lot of attention to cancer news, as you might imagine, lately. With
absolutely.
Yeah, but
that's crazy. Yeah. Wow. I hope this can be applied broadly, and it sounds like it probably would be able to since it's targeted, right?
Yeah. But that was the dream. That was what everybody was so excited about.
Yes, 100%.
Cancer 5-6 years ago is personalized treatment, because there was talk about personalized medicine before all the mRNA stuff.
Yeah.
But it was like only for the super rich, and it would take a long time, and
it was crazy expensive and hard to,
this is relatively inexpensive in terms of like how it's done, the technology that's used, and it's faster. So
crazy
really
that's
cool.
So cool. Well, and thanks, Corbin, for your insight. I loved your details that you added in. So cool.
All right, you ready?
Wow, this is gonna be a hard one to follow, guys.
Should we have reversed the order?
Yes, we really should have. Just wait till you hear. Well, Bobby, while Moderna was saving lives in the lab, there were some other scientists who were on the ocean floor in Italy, scooping up big handfuls of sand and sifting it out to find some 2-centimeter long worms.
It's very important
so that
work.
They could do some studying.
Between segments, you were like, this one's gonna, the Moderna thing's gonna be hard to follow, Bobby.
I even before the show, I reflected this back to you because this is my process of picking a news story. I read it and I'm like, that's a cool thing, and then I start going, and then sometimes like 7/8 of the way through, I'm like, hang on, is this something that only I think is interesting and no one else will care?
You are not.
But
you
by
are
then
not
I'm
so.
too far along.
You are not so strange that you're the only one who finds this interesting. I'm sure. Anyway,
I suppose
tell us
not
all about
only
it. Tell us
one.
all about it.
Well, this 2 centimeter worm is actually crazy cool.
Okay.
And the reason it's really cool is because it has no gut.
It has no. Wait a minute. There's no
It has
like
no mouth.
internal. Oh, see,
Yeah,
this is
it has no
interesting,
anus.
Laura. No.
Yes.
Okay.
And it's really important. The importance of this research was to understand how this worm was getting its energy.
Right. Yeah. Because it's a
Now,
multicellular organism if it's a worm.
Yeah.
Right. So. Okay.
So there are all kinds of ways that nature stores energy, right? We got fats, we got sugars. And there are microorganisms that use bioplastics, naturally occurring bioplastics. They'll generate these like plastics and use them to store energy. One in particular, polyhydroxyalkanoates.
I was not aware
PHAs,
that there were bioplastics in the first place, if I'm being honest.
You know what? Neither did I. I thought that bioplastics were things that we were like, hey, bacteria, look at this new DNA you could use to maybe make some plastic for us. That's what I thought.
Right, because we use bacteria to help us make plastic. Yeah. We
do. Yeah. But now they do it anyway. Not every type of plastic, obviously. But this PHAs is one of the specific ones that was looked at in this study.
Okay.
And I want to just pedal back a little bit because we are going for like here on the show. People have asked this before. We want to hit that sort of middle school understanding of science because most of us, that's kind of where we settle out once we're done formal schooling. So when I say store energy, I mean in chemical form. If you get a bunch of sunlight and you're able to use that energy to make sugar, the actual energy is inside the sugar, the bonds between the molecules within the sugar, or the atoms within the sugar. So plastic is just like that. It's a complex molecule, and there's bonds that take energy to form. So whatever the bacteria is getting its energy from, the sun or from eating other things in its environment, it's able then to make this big molecule and store energy as it.
Right.
Now we thought, don't worry, I'm getting back to the school worm in a second. We thought that only microorganisms can break them down.
The bioplastics.
The bioplastics.
Okay.
Now you just learned that that they make them.
Yeah.
But that we knew that, and we thought they can also break them down.
As opposed to just the environment, is that what you mean?
As opposed to multicellular organisms.
Okay. Oh, like multicellular organisms. It was thought anyway that multicellular organisms could not take these bioplastics and consume them and get energy from them. That's what you're saying.
Exactly.
But only single-celled, only organisms they thought were able to do that.
Exactly. Okay. Now, it is not the case. Scientists have now discovered that, in fact, a wide range of invertebrates in particular have the enzyme to break this down.
Okay.
So one of the key members of this breakthrough was that 2 centimeter long gutless worm, Olavius algarvensis is the name of this worm.
Well done.
I will not be saying it again.
You did great the first time. I'm not.
It's this little white spiral shaped little guy, and the white color. This is crazy. It comes from colonies of bacteria that are like symbiotic with this worm, and they live underneath its skin. That's why it's white. One of these bacteria in particular stores energy and carbon in the form of PHA, this plastic. And so they were like, why is this particular bacteria on this worm? Could it be that this worm can actually process plastic? Can it break it down and make it into more energy? And the answer is yes. Yes, it can.
Wow.
My first question and this is showing my gut bias, I guess, is how could it possibly do that without eating it?
Like
But
how did all that get it? How does it get in there? Yeah.
yeah, exactly. But it just sort of like digests it at the site, like where the bacteria are. It'll like break down the bacteria. The worm will break down the bacteria
Hmm.
and then process whatever's inside of it directly in its cells. So there's
Wow.
no like need for a gut. Yeah, isn't that crazy?
So it's just taking it in through the membranes on the outside of its body.
Mm-hmm. Mm-hmm.
Wow.
Yeah, it just sort of like the bacteria is inside of it. It's in its skin. I'm not sure how it gets there in the first place, but then the worm just sort of like they're basically being farmed, and one of the farms makes PHA, makes plastic.
Mhm.
And there is a specific enzyme that the worm uses to break it down. So a group of researchers, once they found this out, they checked a whole bunch of other animal species and found related enzymes in 66 of them. 66 different animals can already break down plastic.
Wow.
Which means that animals have likely had like this was a wide variety of organisms, and that tells us that animals have had this ability for a pretty long time.
Yeah,
Either
yeah, yeah.
yeah, either they have some shared ancestry where a common ancestor was able to do this and it spread through many different groups, or convergent evolution when you have two totally different organisms creating or evolving towards the same end because it's just one of the pressures in the environment.
Right.
um, and I mean, bioplastics like PHA, apparently they are in as many spaces as there are bacteria who produce them. So you'll find them in soils and sediment and water. They're kind of everywhere naturally occurring.
So is it possible
Um,
then that they did it is all convergent like they all independently evolved these? Is that possible?
um, what the study said is that there was enzymes that were related to this
Okay,
other
so
one.
they have some evidence that it was not independently that they share an ancestor that developed this ability.
It
Yeah.
seems likely that this is
Yeah.
a trait that has stuck around for
Yeah.
quite a long time, that for hundreds of millions of years animals have been digesting this stuff. um However, I didn't get deep into that, so don't
Right. Right.
quote me.
Right.
It
Sure.
might be that that it evolved independently a few times.
Mhm.
I don't think they were able to fully make that claim, but um it's very cool. I mean, PHA is useful in a lot of different things as well, like as a consumer product. We already do make it and use it
Yeah.
as a plastic. It's not, the only one out there. Um and this unfortunately doesn't mean that all microplastics are just going to eventually be consumed by some bacteria or animal. Because most of them are not PHA. Most of them are another type of plastic that is not fully biodegradable and not really useful for an organism,
Right.
that can in fact disrupt, the operations within a body. But I mean, it is also another reason why we'd want to move towards these types of plastic,
Yeah.
knowing that not only can they be degraded by bacteria, but they're useful to many other organisms.
Yeah. That's really neat. That
Yeah.
that that we could if we could use it more. And I just looked it up. I mean, like you already said this that we do use PHA in a lot of there are a lot of applications for it. Like I'm seeing that it's used in all kinds of things like straws and coffee lids and
Yep.
cosmetics and
Hmm.
uh, plastic wrappers and all kinds of stuff. But and that the benefit here is that it's not a petroleum plastic; it's a bioplastic,
Yeah.
right?
Yeah.
Um, but yeah, if we could move in a direction where we're using more of that, and then also now we know so many different organisms that exist and ways that it can be broken down, that's pretty cool.
Hmm.
Well.
Yeah, I was like, this is a cool worm.
It was cool. You were underselling yourself, or you were second guessing yourself.
No, you know what? It's not that. I guess I just know our audience, and our audience wants to hear about weird little worms on the ocean floor.
Yeah. Yep.
And I just have to remember that, because there are people who don't listen to our show who don't want to hear about it, and that's why they don't listen to our show.
Right. Right. We talk about enough weird worms on the ocean floor and miniature robots
Fair.
and insects that
Tiny robots. I appreciate Corbin's question. How did they manage to see and identify the worms? These worms actually like live under the sand, and so the answer is a sieve. They just use a sieve, and then they look for them. Like,
Yeah.
and sometimes that's all they do, right? Like, sometimes science just really comes down to, can you find the organisms with the right kind of sieve?
Yeah. You know what? Imagine, like, what a cool job it must be, but also maybe sometimes frustrating, to just be the science that you do is you go and scoop up piles of dirt or sand,
Yeah.
and you just sift through it to see if you can find something cool.
Is there a worm in here that has no anus? Maybe. Let's find out. I love it. I love it.
Yeah, that's so neat. Yeah. And I think, like, sometimes I don't know that so sometimes you take I spend a lot of time with elementary school kids and going on field trips and doing fun things. And a common thing to do is go to a lake or a pond and scoop up some water and look through it, right, to see what's there just in your backyard or just in a local pond. And there's stuff to be found everywhere, living things, all kinds of stuff, right? And I think, like a lot of times I'll see parents around and I get the sense that they're just like, oh, this is just a cool, fun thing to show kids. But I'm like, no, this is what people do. Like, this is how scientists find things. Like, this is not just like a fun exercise that we do with kids. Like,
yes, yeah.
Like, this is how it's done. That you go out there, you collect samples, and you just look through it, and you might find something you've never seen before.
Totally. And like, it's just teaching observation. Like,
yeah,
this is how you observe the world around you. Notice interesting things and comment on them, and then maybe investigate a little more.
Yeah.
So that's a really foundational piece.
Yeah. Do you have something for us to talk about to be done?
To wrap up. Wrap up.
We really did go fast. I'm not in a hurry or anything.
We were speedy, yeah.
Maybe I can.
I don't have anything.
Maybe I'll give everybody, because I know listeners. I haven't mentioned Stephanie's cancer treatment in a while. Maybe I'll give everybody an update.
Yeah. Do you want me to lead you in?
Yeah, sure. It'll be easy because I just talked about cancer treatment.
Exactly.
All right. Hold on. Let me mark. All right.
So, Bobby, with Stephanie going through chemotherapy for cancer, do you feel like you're paying more attention to cancer stories than you did before?
Oh yeah, for sure. Like, even this particular one that I talked about today, I noticed the headlines more, and I'm like, I'm going to read about that. I have no misconception that I'm going to read some breakthrough that is going to that we're going to be using tomorrow for
right,
Stephanie's.
Of course.
But I am obviously thinking about it more and I'm just more interested. I'm learning in general. I'm learning more about how cancer is treated, obviously. So I'm just more tuned in to that. So, and then what happens is I'll read it, and then I'll either find it really, really usually one or both of these things happen, which is that I'll read it and find it really, really interesting, or I'll spend so much time reading about something and following a thread. I'm like, well, I don't have time to read anything else now, so I guess I better talk
Yeah,
about
yeah.
this.
And how's she doing? I know she's in the middle of treatment.
Yeah, she's doing great. So I can't remember the last time I mentioned where she was in her treatment because we've had some weird scheduling.
Yeah.
The way we've been recording episodes to get through the summer, but she of course had her her surgery. She got a mastectomy. That went really, really well. She got to take the silver lining about that is she got to take 5 weeks off of work and hang out with the kids and me and just like over the summer. Like, wow, what great
Yeah,
timing,
yeah,
because
yeah.
honestly, and this is her experience, it's not everybody's experience, but it wasn't
Mhm.
that bad. The surgery wasn't.
Yeah, because hers was not super duper far spread. They didn't have to do
Yeah,
crazy invasive
yeah, it
removal.
wasn't.
Yeah,
I mean, it was a mastectomy, so it
for
was
sure, for sure.
invasive in that sense, but it wasn't like really deep into the chest wall, I guess.
Mhm,
So she
mhm.
recovered pretty quickly. She was up and moving around and begging to do chores around the house after like a week and a half, really, and then wondering like, why am I not just back at work? And I'm like, come on, take it easy. Right?
Yeah, yeah. Yeah, take this as it comes.
Yeah, but she's back at work, and so there was a bunch of tests that happened. We learned so much about that. They do all this. They sent it off to do what's called a what is I forget all the words suddenly, but it's a test that they do. They tested the DNA of the tumor.
Mm. Mhm.
When they do the surgery, they take it and immediately pull it out and send it down to a pathology lab in the hospital, right away, and they check it to see if they take the lymph nodes out. Like there's an equation or something based on the size and where it's located and stuff. But
Sure.
that's
Yeah.
that tells them how many lymph nodes they're going to take out, and then they send those off to a lab right away, and then it comes back and tells them if there's any cancer cells in there, which would inform whether they need to take more lymph nodes, right?
Mhm.
So they told us that they didn't find any cancer cells in the lymph nodes that they had to take, which was great news. But then we found out later when they did more pathology on it that there were what they call micrometastases, whatever, tiny tumors in those
Yeah.
things that
Okay.
they didn't notice, but so small that they're like considered stage 0 or something like that
Okay.
in those.
Yeah.
So that wasn't really that big of a deal to them. For them, it was always going to be that she had to get chemo anyway because she was young, or at least
Yeah.
that's what they were always going to recommend, of course.
Yeah.
So that's what we decided to do, and that's she's it's about as good as it could. I keep telling people it's about as good as it could possibly be in terms of the treatment that we have to do. It's a 12-week chemo treatment, but she only has to get 4 chemo infusions over those 12 weeks. She gets 3 weeks between them, which is great because
Some recovery.
Yeah. Of the chemo treatment is rough, let me tell you.
Yeah. I've heard it's really bad.
Yeah, and so I can't imagine. I feel for people who have to do it every week,
Oh yeah.
But we've gotten 2 infusions. In fact, this week was her second one, so we only have 2 more to go. So that's cool. That's exciting. We're halfway through, and she's been taking it well. It's really hard, like I said, the week of, but after she recovers, it's like back to normal. She lost her hair, and she's shaved her head, and she let the kids cut her hair and shave her head and everything, and that was fun.
That's good. That's good.
They really enjoyed that. We just made some fun out of it, and so we're doing well. What's cool, I think I told you this. What's cool is we already had a Disney World trip planned in early in October, and the timing worked out perfectly where her last chemo infusion is going to be about 10 days before we leave for Disney World. And we've talked to the oncologists about this. They're not worried about it or anything like that.
Good. Yeah.
So they're like, yeah, go, of course. And the oncologist even said, because we were asking about the timing, she was looking at the calendar. She was like, well, if you start here, like you're going to, well, then you'll be done here. And guess what? It'll be a great time to celebrate in Disney World that you're done with chemo.
Amazing.
So we're really looking forward to that too. And but we're doing great. To answer to the short answer to your question is we're really doing great. And
I'm glad.
I do think I should say thank you to everyone who's listening who has reached out to us and said that they're thinking about us, and I've had so many people just share their stories of people that they know or cancer that they've gone through or they're in their family or stuff like that. It's maybe sounds cliche, but it really is encouraging to hear those stories. So thank you to everybody, but we're doing great. We're doing awesome.
I'm so happy to hear that. Yeah. Well, I hope she manages through the next two. Yeah. I know it's great to hear you're doing well, but I'm sure those sick days are no picnic. So
yeah.
So yeah, all the best to you and Steph as you keep going through this.
Yeah, thank you. Well, that is going to be it for this episode of All Around Science. Thank you, everybody, for listening. Thank you to our live listeners on the live show. I don't know if we mentioned it at the beginning of the show proper, but we were recording this one live. It was our monthly live show for August. So thanks to all the people in the chat. And if you've got questions or feedback that you want to send us, you can email us at contact@allaroundscience.com.
Head to allaroundscience.com for our socials and join our Discord server if you want to hear more about gutless worms.
My name's Bobby.
I'm Maura.
And we'll see you next week for some more science stuff. All right. Now we're going to, for those, I think I see some new names this week. We always like to tell people we're writing our cold open teaser thing. So we're just staring blankly.
And mine's quick.
Yeah.
Mine's quick.
Mine too. Here we go.
All right. Oh no, I'm ready. Okay, we're good. On today's episode,
personalized cancer vaccines are coming.
And this worm can eat plastic.
All that and more today on All Around Science. Man.
Eat might be the wrong word there.
Eat. Oh. My.
Did Steph didn't have to do radiation, did she?
Nope. You know what the hardest part of the whole thing is so the blessing and the curse of her situation being so good, right? Like she's young. Well, actually, paradoxical. It's not paradoxical, but it just was. I didn't expect it. Being young actually makes it so they want to treat it more aggressively, right?
Yeah, that makes sense.
Yeah, and I just didn't. I was like, oh, that makes sense now that I think about it, but I never thought. I didn't think about that before. But her breast cancer is like, it's the hormone positive kind, so it responds to hormones, and that's good in terms of making it a treatment, because that's a treatment option, right?
Yeah. Yeah.
And then it wasn't that it wasn't spread or anything. Oh, the thing I didn't mention was they did an oncotype test, which the results came back from that. An oncotype test, if you don't know, is they test the tumor and they send it off to like California or something, and they get it tested, and they basically give it a score to tell you how likely it is to come back. And her score was really low, like super low, like in the single digits. So it's like a score of 1 to 100, and hers was super low. And so with it being super low, with it not having spread very far, with it being caught early, with it being hormone positive, like all the outcome, like everything was really good. So the weird, unintuitive, tough part about that is that they're just like, well, here are all your options. Which one do you want to do?
Yeah.
And you're like, what? No. Don't ask
Like,
us.
no,
what
you tell me.
You tell us what to do. Like,
doctors do that all the time, and I'm like, I appreciate that you're not just forcing me to do something, but truly, my friend, you've had so much more schooling. What would you do? That's almost always my answer.
Yeah.
And it's the better way to go outside of like being told you're doing this, but like,
yeah. And we did have a long conversation with the oncologist. That's one doctor that does not rush when you meet with them. Like they it's the longest I've ever had a doctor. Like every time we have a visit with the oncologist, she sits there and she's like, I'm here to talk to you.
Amazing.
And
so good.
And so we have lots of long conversations about, like, we even asked her, because one of the great things about the oncologist she has is that she is also around our age, and she has kids, and she had breast cancer.
Okay.
And so like her situation is similar to Stephanie's. And
crazy.
But we asked her just straight up. We were like, okay, yes, I get that we need to make a decision, but like, what would you do? Please just tell us.
Totally.
Like,
totally.
And
yeah. Okay, sorry, I really have to go.
Okay.
But thanks everybody for coming.
Yeah.
We will see you later.
I gotta go watch a movie anyway. Bye-bye.
Bye.